Lesson 415, Circles and Coordinate Plane, Part 3. In this lesson, we're going to translate a circle on the coordinate plane. And we're also going to be sketching and writing equations of circles that we only know 3 points, but we don't know the center. To start with, we know that the radius and chord theorem states that a radius that is perpendicular to a chord of a circle bisects the chord. And we also know that the converse of this theorem suggests that the perpendicular bisector of a chord of a circle passes through the center of a circle. So in this figure, A is the center of the circle and BC equals 12, and they want to know what is DC. Well, right here is B going all the way down to C. That's 12, and they want to know what DC is. Well, segment BC is both the diameter and a chord. Therefore, AB equals AC. AB and AC are also the radii, as is AD. Since BC equals 12, you know that AC equals AD, which equals 6. Now triangle DAC, you got DAC is a right triangle, and we know that because of this little box right here. So we're going to get to use the Pythagorean theorem to figure out what DC equals. Well, we know that AD is 6, and we know AC is 6. So if we have 6 squared plus 6 squared is going to equal DC squared. And I think we probably need to ignore these congruent marks right here because I don't believe those are supposed to be there. So when we square 6, we get 36 plus 36 equals DC squared. That's going to give us 72 equals DC squared. Then remember, we get the square root of both sides. So when we do that, we find out that DC equals 8.49 approximately, because remember, anytime you have a decimal, it's an approximation. Okay, so yeah, let's go ahead and ignore these congruent marks because they don't really equal 6. Okay, the perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter of a triangle. The circumcenter may be inside, on, or outside the triangle. Now here we've got a triangle, and we're going to create the perpendicular bisectors. And the bisectors are just segments. So there's the first one, there's the second one, and there's the third one. Now at that point where they all intersect is called the circumcenter. And what is special about the circumcenter is it is also the center of a circle. So that's going to help us out in solving some problems. But before we work on that, we want to talk about translating a circle. We've got this circle here with the center 2, -3. Here you see the formula or the equation for that circle. The radius is 4 units. So r squared is going to be 16. Now what I just did is I translated that circle 8 units to the left, and now I'm going to translate it 4 units up. And notice what's changing is the center and the point on the circle. That's all that's changing. So now I can use that information that I have as the center and the point on the circle to write an equation. So remember, this sign is always going to be the opposite. So if this is a -6, I'm going to have a +6 here. And since this is a +1, it's going to have a -1 right here in the equation. So there is my new equation after my translation. Notice that the radius didn't change at all. Okay, Now we're going to do the equation of a circle given 3 points, and notice I don't know what the center is. I could probably figure it out pretty easy, but we're not going to. We're going to do it the hard way. And if you see, I got 3 points on the circle, okay? And I just used the lesson or the example that was in the LMS. It says, well, before I get to that part, it says to write an equation you need to know the center, which is HK, and the length of the radius R. But sometimes you don't know these, and you've got to find out the center and the radius in order to write the equation. So here's the part that's out of the LMS. It says, suppose you and 2 friends live at points A, B, and C on a circle when your town is displayed on a coordinate system. The library is located the same distance from each of your homes, and they want to know what is the coordinate of the library. Well, since the library is equidistant from all 3 homes, that means that the coordinates of the library are also the coordinates of the center of the circle. So to find the center, we go ahead and construct segments to form a triangle ABC. And now, just like I showed you earlier, we're going to construct the perpendicular bisectors of the chords AB, BC, and AC. There we go. There's my perpendicular bisectors, the green lines. And you can tell they're perpendicular bisectors. Perpendiculars because I got the little boxes there. Bisectors, I tried to get as close to the middle as I could. If you measured, it might be off a little bit, but I tried. This is why you got to use a real compass and a real straight edge to do these, because you're just guesstimating when you do it on a computer. Okay. Of course, the center of the circle is going to be where all 3 bisectors meet, and I put a dot right there. So now we know the center, or actually the library, is at coordinates 0, 1. And now that we know the center, we can actually write the equation. So there we go. We've got that information. And remember, to write the equation, you just need the center and a point on the circle. So there's the equation. I got to fill in the points. Now we're going to use point A, where -2 and -4 are the values for x and y. And for we're going to use HK, which is 0 and 1. We're going to use these 2 points to figure out what our radius is going to be. So there we go. We plug in all of our information. That gets us r squared. And now we just got to simplify it. So of course you got -2 minus 0 is going to give you -2. -4 minus 1 is going to give you -5. So when you square those, you get -2 squared is 4, -5 squared is 25. So I got 4 plus 25 equals r squared. Add those together, I get 29 is r squared. Okay, now that I know what r squared is, I can use my center to write the equation. Okay, so I'm going to take and I'm going to plug 0 and 1 in for h and k, and I'm going to plug the 29 in for the r squared. There we go. Now I can go ahead and simplify this because this says x minus 0, and we know x minus 0 is just x. So there's going to be my equation for this circle. Now I'm going to go ahead and do another example. Here, the first thing you're going to do is create the triangle, which are just going to be chords of the circle. And then when you get finished doing that, you're going to create your perpendicular bisectors of each chord. And then that's what it would look like. See how this circumcenter is on the inside? Looks like I might be off just a little bit, but it's close enough for this example. Okay, so once you've done that, you'll know where the center is. And once you know that center, now you've got all the information you need to write the equation. So first we got to figure out what r squared is, and the point I'm going to use in this example is point B and D to figure out what r squared is. So I'll plug all that information in, simplify it. Then I go ahead and square the 3 and 2, add the 9 and 4 together, and I get 13 equals r squared. So now that I know the center is negative 1, 2, I know r squared is 13, I can write my equation of the circle. So you're just going to take that standard equation, plug in the h, plug in the k, and the r squared. And when you do that, you get, I think I wrote that backwards. I sure did. I didn't write the problem backwards. I wrote the coordinates backwards. If you look, x is supposed to be 2, y is supposed to be negative 1. Okay, so in this lesson we learned that by the converse of the radius and chord theorem, given 3 points on a circle, the center of the circle is the circumcenter of the triangle formed by the chords, whose endpoints are the 3 points. To translate a circle in a coordinate plane, you may translate the center of the circle in 1 point on the circle, and you can find the values of h and k in the equation of a circle depending on the amount of the horizontal or vertical shift caused by the translation. You need to go in and read the LMS lesson 415, Circles in Coordinate Plane Part 3, complete the student guide, add any notes that you need to after you read through the lesson in the reference guide, complete the following problems in the problem set. When you get finished with me, you need to when you get finished with the problem sets, you need to contact me or attend tutoring if you have any questions before completing the 415 quiz. Oops, skip that last one. And please give me your course end section number with all communication, because that helps me help you faster. That's going to be it for lesson 415. Thanks for listening.